everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we are going to discuss about the topic scalar and vector point function. So now in which we will discuss about gradient, divergent, curl and scalar potential function. So in detail we will discuss about definition of gradient, vector and scalar point function. So we can see here a definition of divergent and curl. The problems based on vector and scalar point function. So in detail we will discuss about these topics. So first one is vector differential operator. That is the vector differential operator. This is the symbol which is used for vector differential operator, which is defined as, so it is called gradient or grade we can call. The grade is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. So the next one is gradient of a scalar point function. The scalar point function is nothing but, let pi of x comma y comma z be a scalar point function of the position which is defined in some region of space. So we can see here the vector function. The vector, it's nothing but it has not only magnitude, it has direction also. So now here I, j, k, they are mutually perpendicular vectors and pi it is there that is connected to our gradient, then it will become I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z, which is known as gradient of pi and which is denoted by grade pi, or we can use the symbol grade pi. Now we can see here grade pi, that is I dou by dou x plus j dou by dou y k dou by dou z into pi. The next step, we are taking this pi inside. Then I into dou pi by dou x, j into dou pi by dou y. Just we have taken the pi inside. Then it has become k into dou pi by dou z. The definition of divergence of your vector, that is, let f be continuously, that is the particular f is a vector point function, that particular vector point function which is continuous and that is differentiable also. Then we will call I dot the particular vector function, that is our f bar is our vector function. That vector function with respect to x, with respect to y and with respect to z, partially we are going to do differentiation and the dot product along with our mutually perpendicular vectors I, j, k, which is called divergence of our vector function f, which can be in a simplified form. It can be written as div f vector. Now we can see here div f vector, it's nothing but the same which is written already what we discussed, the same one, the name we are giving div f. So the div f, from which the f, the vector function, which has been taken out when we are comparing with the previous step and this step. Here the vector function f which has been brought outside. This completely we know it. This formula is nothing but our gradient. So we can write divergent F, divergence F is nothing but grade dot F. That is our F in the sense it is our vector function. So now always we can remember, if we do the dot product, the result will be in scalar. That means it has magnitude, only magnitude, scalar point function. The definition of solenoidal vector. Just now we discussed about divergence. If the divergence which is equal to 0, then we will call that particular the vector function is solenoidal. Next, we can see here a vector point function f which is said to be solenoidal if divergent f equal to 0. Curl of your vector. Divergent, to remember, dot product will dominate there, whereas curl of your vector, cross product will dominate. So the cross product, if you are taking, that is f vector, which is continuous and differentiable vector point function. So we can see here I cross dou f by dou x, j cross dou f by dou y, k cross dou f by dou z, which is called curl of f vector, which is denoted by gradient cross f vector. Otherwise, simply we can write curl the given vector function f. The bar denotes that is vector. So now a vector f, which is said to be irrotational if curl f equal to 0 vector. So very simple thing so far what we have discussed. If divergent f which is equal to 0, then solenoidal, and curl f which is equal to 0, then it is irrotational. Here we can see it. If given f bar is irrotational, that means curl f which is equal to 0. Irrotational, the word which represents compulsory the curl f which is equal to 0, then the particular point there exists a scalar function. Given function is f bar, that is irrotational. Condition is satisfied. Then there exists a function pi. Then relation between our f and pi is nothing but f equal to gradient pi. Then this point is, the pi is called scalar potential of f bar. So that's what which is written here. So f bar equal to gradient pi. Now we will concentrate the problem. The problem is if a equal to x plus y plus z, b equal to x square plus y square plus z square, and c equal to xy plus yz plus zx. So what they are asking us to do it, prove that gradient A, gradient B, gradient C, it is in vector form which is equal to 0. This we have to prove it. Before that, first we have to find what is gradient A. Gradient, we know the formula, that is I dou by dou x plus j dou by dou y plus k dou by dou z. First, using that, we will evaluate what is grade A. So now we will move to the solution. That is, given A equal to x plus y plus z, dou A by dou x, partially. Dou represents partial differentiation notation. So we have to do A with respect to x. So we are searching the equation where the x variable it is there. Here is our x variable. So the partial differentiation is 1 partial. So x, y, z, three variables are there. Only we are focusing on x. Other variables we are neglecting. So 1 is the result we obtained for dou a by dou x. Next, similarly, dou a by dou y. So here also our the variable is y, then the partial differentiation is 1. So the last one is z, dou a by dou z, that differentiation is also 1. Now we can see it here. First, this we are focusing, that is a gradient A. So the gradient A here with the mathematical symbol notation, which is equal to I into dou by dou x plus j into dou by dou y plus k into dou by dou z, this A which is written as it is. Now the next step, we will take the A inside the bracket. So after taking this A inside the bracket, it has become I into dou A by dou x plus j into dou A by dou y plus k into dou A by dou z. So next, what we obtained, dou A by dou x 1, dou A by dou y 1 and dou A by dou z is 1. So we can see it I plus j plus k. So the first one, the gradient A, the work what related to that we completed. Next, now we will move to B. So the B which is given x square plus y square plus z square. What is the treatment? What are the steps we follow for gradient A? The same steps we will follow here also. That is, here we can see the animation part which is given in the different color, that is the variables x, y, z, that is it represents partially we are doing differentiation regarding those variables. So the first one is dou b by dou x. So here we are searching what is our variable related to x. Only this is the place we have the variable x square. So the partial differentiation is 2x. The next one is dou b by dou y. Here the differentiation is 2y. So the third one, dou c by, we can see it here. Sorry, here also b only, because completely we are doing regarding b, the differentiation related to x, y, z. So now here also 2z. So the partial differentiation regarding b with respect to x, y, z we completed so far. Now the gradient b, mathematically the symbol notation we used it. This is the for gradient I dou by dou x plus j dou by dou y plus k dou by dou z, the b which is written as it is. Next step, we have taken the b inside. So the three places it is placed it. So I dou b by dou x plus j dou b by dou y plus k dou b by dou z. We can see it here now. So we moved it now. We completed one. This is the result we obtained it. So this is replaced by this particular place, and this is replaced by this place, and here which is replaced it. So the gradient b, what we obtained is 2xi plus 2yj plus 2zk. Now we will concentrate our gradient C we will find out, for which our C equal to xy plus yz plus zx. We can see it here. The same similar step. We are finding grade C. C we will take it inside. After taking inside, this is the step we got it. Actually, it is placed before itself. That is I into dou C by dou x plus j into dou C by dou y plus k into dou C by dou z. This now xy plus yz plus zx. So the three terms are there. The three terms we have to do partially differentiation with respect to x. Yes, we can see here the animated one. Here the color which is kept to understand the level more, x, y, z. They are in red color. That is, we are going to do partially the C vector with respect to x, y, z partially. The symbol which it denotes, we are doing not a differentiation, partial differentiation. So we will search first in these three terms where x variable is there. Here, here. Only two places. So x, the differentiation is 1. So 1 into y, y. Here also 1 into z, z. So y plus z. Next we are doing partial differentiation with respect to y. We are searching here, the y terms are there. So the y differentiation is 1. 1 into x, x. Here we are seeing y differentiation is 1. 1 into z, z. Here there is no term at all. We neglect it. So the last one is with respect to z. Here what I am circling, these two terms, they have the variable z. So z, the differentiation is 1. So y into 1, y. Here 1 into x. So this is the result we obtained it. That is a grade A and grade B and grade C. So we discussed in detail about it. But the result we have to prove it. That is the vector form grade A, grade B, and grade C. So we will find the determinant, and after finding the result, the determinant, we will achieve the result. So the next problem is, we are seeing here, show that gradient of f of r, which is equal to f dash of r divided by r, which is equal to into r vector, where r vector equal to xi plus yj plus zk. So the solution is, let r vector equal to xi plus yj plus zk, and let r equal to here modulus of r vector. Here the modulus, if you are noticing, r square equal to x square plus y square plus z square, thus differentiating with respect to x, y and z partially. So when we are doing the differentiation partially, first with respect to x, the left position is 2r dou r by dou x, which is equal to 2x. The next one is this simplified one we are getting dou r by dou x, the two getting cancelled, we obtained x by r. Next, with respect to y, similar way we obtained it dou r by dou y, which is equal to y by r. The finally dou r by dou z, which is equal to z by r. Now the gradient f of r, which is equal to, here the completely the gradient which is written I dou by dou x plus j dou by dou y plus k dou by dou z f of r. Next, this f of r we will take inside, then it has become I into dou f of r by dou x plus j dou f of r by dou y plus k dou f of r by dou z. We have to do the differentiation now. The function is f, which is defined in terms of r. First, that f for differentiation is f dash, that is f dash of r. Again r, the differentiation if we do, that is dou r by dou x. Already in advance we found dou r by dou x. It is nothing but x by r. The same manner, the next one is plus j f dash of r dou r by dou y. It's nothing but y by r. The final one is k f dash of r into z by r. We can see here f dash of r in this completely f dash of r, which is common. So we have taken outside, even this r is also common, we have taken outside. The leftover is xi, yj and zk, that we kept it inside. Xi plus yj plus zk, it's nothing but r vector. So f dash of r divided by r into r vector, we proved it. So the next one problem is find the directional derivative of f equal to xy plus yz plus zx in the direction of vector I plus 2j plus 2k at the point 1, 2, 0. First, the given f is nothing but xy plus yz plus zx. Now, dou f by dou x, same this already we discussed the same function before itself, that is dou f by dou x, it's nothing but y plus z. Dou f by dou y, it's x plus z, that is f partially with respect to y we did. Here f partially with respect to z, the result is x plus y. Now gradient f, that is the notation grade f equal to the grade, the particular place which is replaced by I dou by dou x plus j dou by dou y plus k dou by dou z, and this f which is written. Now this f we have taken inside, then I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. So this already we found dou f by dou x. Here it is there. Just we replaced it into I. Dou f by dou y, x plus y, which is replaced in the particular place. So after replacing, we obtained x plus z of j. The final one is dou f by dou z, that is x plus y of k. If E is the unit vector in the direction, that is of the vector I plus 2j plus 2k, this is which is given in our question itself, then this unit vector to find the particular vector divided by its modulus of that vector. So this is given in our question, that is I plus 2j plus 2k divided by square root of, here the I coefficient is 1 square, j coefficient is 2 square, here also the k coefficient is 2, 2 square. So 1 by, here the particular thing is 9. So 1 by 3 of I plus 2j plus 2k. Now the directional derivative of f along the given direction is, this is the formula for the directional derivative, that is E vector, that is unit vector dot grade f. The f is nothing but our vector function. Now 1 by 3 of what we obtained here, this is our unit vector, 1 by 3 of I plus 2j plus 2k, and this dot which is written here, y plus z of I plus x plus z of j plus x plus y of k. Here 1 by 3 of dot product I dot I, which is equal to 1, I dot I, which is equal to 1, j dot j, which is equal to 1, k dot k, which is equal to 1. This only exists, remaining and all vanished. So the dot product after doing, we obtained 1 by 3 of, just 1 by 3, we have taken it outside, y plus z plus these two multiplying 2 of x plus z, here 2 of x plus y. So what we obtained, the result we wanted at this particular point, that is 1, 2, 0, the value we wanted, that is 1 by 3 of, so we can see it here, this place only we are going to substitute. 1 is the position, the place for x, 2 the place for y variable, and for the z variable is 0. In this is the result, the previous slide lost what we obtained it. So 1 by 3 of, so this y is replaced by 2, z is replaced by 0, here we can notice it, plus 2 of, here the result we can notice it, 1 plus 0, plus 2 of, here also 1 plus 2, the result we can see it. So 1 by 3 of 2, 2 and 6. So 10 by 3 we obtained for the second problem result. Now we will move to the next problem. Find the directional derivative of, here pi of x comma y comma z, which is given x square y z plus 4xz square at the point. That is, at this point 1 comma minus 2 comma minus 1 in the direction normal to the surface f of x comma y comma z. This is one function. Two functions are given in this particular problem. That is, find the directional derivative of pi in terms of x, y, z variables at the particular point 1 comma minus 2 comma minus 1 in the direction normal to the surface. Another function for that, the point which is given. So this directional derivative we have to find. Already we discussed the previous problem also, directional derivative, that is E dot grade f is a formula which we used for the before problem. So now the given function, that is pi of x comma y comma z, which is equal to x square yz plus 4x z square. So dou pi by dou x, we have to do the function pi, which is defined in the variables x, y, z. Partially we have to do it x. Yes, here x is there, here also x is there. Y, z, treating them as constant, we will write it as it is. X square, that is 2x. Here x, we can see it this place also. Here x should not come at all. 4z square. Here we can see it, dou pi by dou y. Here the y, which is 1. So 1 into x square z. Here there is no y term at all. Next, the finally dou pi by dou z, for which z we are doing. Here it is 1 into x square pi. Here z square is there, 2z, that is 8xz. We need now a gradient pi. So the gradient pi, grade pi. So I dou by dou x plus j dou by dou y plus k dou by dou z of pi. We are taking the pi inside, so it is taking its position. After taking pi its position, then it has become I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. So now here I is there, dou pi by dou x. So which is replaced by, here we can see it here. So we obtained the result 2xyz plus 4z square I plus x square z j plus x square y plus 8xz k. Because here also x term is there, but x, the differentiation is 1 into 4z square. So we obtained here, this is the result we obtained it. So at the point, now we have to find 1 comma minus 2 comma minus 1. So that is, we are substituting the particular places. Here this x, y, z, completely this we are multiplying 2, already 2 exists, 4. So 4z square, that is here minus 1 square, it has become plus 4. So totally 8i we obtained it. And coming to the second one, that is here this is replaced by 1 and z is replaced by minus 1. So minus j we obtained it. Here coming to the point, the last one, that is 1 into minus 2. Here y value is minus 2 and 1 into this term is minus 1. So minus 1 into plus 8 minus 8. So we obtained the result 8i minus j minus 10k. Now, so regarding the function pi, the work is completed. Now, another function which is given, f, which is defined in the variable x comma y comma z, which is equal to x log z minus y square. For that, dou f by dou x. So we have to do partially with respect to x. So if you do partially with respect to x, it is 1 into log z is log z. Dou f by dou y, that is here y square, that is 2y, already negative sign, it is there, minus 2y. The final one is dou f by dou z. So here you can notice it, x is treated as a constant, which is written as it is log z. Log z is nothing but 1 by z. So grade f mathematically with the notation and the gradient formula into f. We have taken the f, the vector function, to the particular places and it occupied its positions. That position is occupied. Afterwards, I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So this values what we obtained, we are going to substitute in the respective places. So the respective places we are substituting, then log z of I and minus 2y of j plus x by z of k. Now at the particular point, that is minus 1, 2, 1, then if you are substituting here, this is z log 1, which is 0. Here minus 2y into 2, so minus 4j. X is minus 1 divided by 1, minus 1 into k minus k. Next up, so pi at the particular point which is given in the question, we did f, we did gradient f. At the particular point, we substituted the values x, y, z in the respective places. We obtained minus 4j minus k. Now, suppose E vector is the unit vector in the direction of the vector, because they told actually unit vector normal to the surface. This f which is given, so what we obtained is minus 4j minus k, that we have to convert it into unit vector. For the conversion, we know it very well, the particular vector divided by its modulus. So what we obtained the gradient f, it's nothing but minus 4j minus k divided by its modulus. The modulus, in the meaning of it, what it represents, that is square root of, here j before the component, minus 4 square, it's nothing but 16. K for that minus 1, the square we are taking plus 1. So we obtained the result minus 4j minus k divided by root 70. So the directional derivative is grade pi dot grade f divided by modulus of grade f. So what we obtained the what is that, the function what is given for the pi, this already the obtained result we are substituting in the particular places. So after the substitution, that is the grade pi which is replaced by 8i minus j minus 10k, this dot which is written as it is, and this is what we obtained the result of just now, minus 4j minus k divided by root 17. Here we have to do the dot product. We know very well the dot product I dot I, but there is unfortunately there is no I term here, so it is neglected. Next, j dot j exists, so here minus 1, here minus 4 is there, so we can see it. So plus 4, and this minus 10 into minus 1 plus 10, so it has become 14 divided by root 17. So the before one we obtained the result 14, but root 17 is the answer for the previous problem. Next we will move to the new problem. Find a unit normal vector to the given surface. So here which is given x square y plus 2xz, which is equal to 4 at the point 2, minus 2, 3. So the solution which is given, f, the function which is defined in terms of variables x, y, z. So we are bringing as a one side x square y plus 2xz minus 4, which is equal to 0. We are finding dou f by dou x. So x, these totally 3 terms are there. The first 2 terms, x variable is dominating. So here x square, the differentiation is 2x. 2x into y, 2xy. Here x differentiation is 1. So 1 into 2 is z, 2 is z. So f, the vector function, which we did partially with respect to x. So complete the notation mathematically, dou f by dou x. Now the next one is dou f by dou y. Here in this particular question, we are searching where is y. Only the first term only it has the variable y. So the y, the differentiation is 1. 1 into x square, it is x square. Dou f by dou z. Here it is 1 into 2x. Here we can see it gradient f. The mathematically the notation is that is grade f. Here I dou by dou x plus j dou by dou y plus k dou by dou z f. We can take f inside. So I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z. So the particular what we obtained the result already in the previous slide what we discussed it. So those values in the particular places we are going to replace it. So dou f by dou x which is we are going to replace by this value. Dou f by dou y we are going to replace by this value, and the finally dou f by dou z by 2x. So we replaced it. After replacing along with the mutually perpendicular vector, the result is 2xy plus 2z of I plus x square j plus 2xk. So at the particular point that is 2 comma minus 2 comma 3. So x we are going to replace it by x, y by minus 2, z by 3. So after replacing, here we are going to replace it xy. So we can see it already 2xy plus 2z. So 2 minus 2 plus 2 into 3. So here minus 8 plus 6, we obtained minus 2i. This is x square minus 2 the whole square, 4. Next 2x, 2, 4. So we obtained minus 2i plus 4j plus 4k. So the 2 is common, we have taken it outside. So the 2 of minus I plus 2j plus 2k. If E vector is the unit vector in the direction of the vector 2 of minus I plus 2j plus 2k, then E vector equal to, that is the particular the vector, to convert it into unit vector, the formula is gradient of that particular vector. Our particular vector is f divided by modulus of that particular gradient of that vector. This is the result what we obtained, divided by the 2 as it is. Square root of the I, here before minus 1 is the coefficient, 1 square y, 2 square 4, here 2 square 4. 2 they are getting cancelled. So the leftover is minus I plus 2j plus 2k divided by root 9, that is 3. So now we obtained the previous problem, the unit normal vector, the result minus I plus 2j plus 2k divided by 3. Now we will concentrate our problem, evaluate the angle between the normals to the surface, that is xy, which is equal to z square at the points. Here the first point which is given 4, 1, 2. That is x, y, z. X is 4, y is 1, z equal to 2. And 3, 3, minus 3. That is x, y, z. They are 3, 3, minus 3 respectively. First, the solution we will concentrate now. So the focusing on the solution, first we are writing what is given in the question. So given surface, that is f of x, y, z, this is the vector function which is given in terms of the variables x, y, z. So xy minus z square, this is the function. It is our function which is given in our question. First, we are taking n1 vector and n2 vector be the normals for our given surface. At the point, the first point which is given in our question 4, 1, 2, the second one which is given 3, 3, minus 3. First we will differentiate with respect to x, y, z partially our function. So that is dou f by dou x. This is our function. In this we are searching where two terms are there. In the two terms, where is our variable x? Only the first term which has the variable x. So x, the variable is 1. 1 into y, y. So the second one is dou f by dou y. Here our y variable is y. The differentiation is 1. 1 into x, x. The final one is dou f by dou z. Here the last one, z square. That is 2z. Already in the problem negative sign is there, minus 2z. So the gradient f we have to find. So the gradient f, so the mathematical symbol is, which is written grade f. The particular grade, the formula is replaced it. I dou by dou x plus j dou by dou y plus k dou by dou z f. So we can see here I dou f by dou x plus j dou f by dou y plus k dou f by dou z. So this is the value, already we found it, that we are going to replace it. That is dou f by dou x, which is replaced by y, dou f by dou y, which is replaced by x, dou f by dou z, which is replaced by minus 2z. After replacing, we got your vector, that is yi plus xj minus 2zk. At the particular point, the first point which is given 4, 1, 2, that is wherever x, we have to replace it. This is x, y, z. So x, here first yi is there, y is taking 1. So we are going to substitute here. We can see the answer. Yes, it is substituted. It is correct. X, the value is 4, which is substituted. And z value is 2. Here already minus 2 is there, minus 4k. So we obtained the particular surface of the function. This partial notations we did. We substituted, we obtained, this is the result. And this particular point also substituted, we obtained the final result, I plus 4j minus 4k. Thus we will name it as n1 vector, normal vector. Next, the same surface, one more point which is given. So this is the thing. Here we are going to substitute these values x, y, z. So here y is replaced by, here we can see it 3, because here y value is 3. X, that is replaced by 3, we got it 3j. Here z value is minus 3. Already minus 2 is there, so plus 6k. So we can, this we will name it as n2 vector. So the n2 vector is nothing but 3i plus 3j plus 6k. Let theta be the angle between two normals. So the formula for the angle between the two normals are cos theta equal to vector n1 and vector n2. That is the dot product of n1 and n2 divided by modulus of n1 into modulus of n2. The up one is dot product, the down one is just a product. So now, so the n1 completely we replaced it. What is the result? We obtained it. n2 we replaced it in the particular place. The dot product we are going to do it now. We know the dot product I dot I, j dot j, k dot k exist. Thus, n1 vector modulus, that is the coefficients square root of Here the coefficient is 1, 1 square 1, 4 square 16, minus 4 square 16. So the modulus of n1 we completed. So the next one is square root of 3 square 9 plus 3 square 9 plus 6 square 36. We completed modulus of n2 vector. So the upper part, we have to do the dot product. So here, 1 into 3, that is I dot I, which is the value is 1. The next j dot j, the value is 1. 4 3s are 12. And here k dot k is 1. So minus 4 into 6 minus 24. So the final result we obtained minus 9 by square root 37 into square root 54. So we will come to a conclusion of this topic, scalar and vector point function, that is gradient, divergent, curl, and scalar potential function. This topic, first, vector differential operator. It's nothing but gradient. So the gradient I dou by dou x plus j, dou by dou y plus k dou by dou z. Here, a scalar point function. That is, the gradient is there. In that, gradient dou by dou x plus j, dou by dou y plus k dou by dou z of pi. The pi we are taking inside. The divergence of a vector, it's nothing but div f. That is, gradient dot f we are finding. Dot product is the dominating one in divergence. And if that divergence, div f, which is equal to 0, then it is solenoidal. The cross curl, which is equal to 0, then it is irrotational vector. And scalar potential. And one more also, we discussed it. Curl is cross product, gradient cross f. Scalar potential, that is the given function, suppose f is there, then there exists a scalar pi. Then relationship between this f and pi, which is defined, we can tell scalar potential. Then we moved to your problem. Even the initial discussion of the problem, we found grade A, grade B, grade C. That's what which is explained there. And the proving, in the sense what we obtained the result, grade A, grade B, grade C, that we have to find the determinant. That actually initially it was not told. The determinant we will find. We are finding, when you are finding the determinant, the two rows are equal. Then we know it, according to the determinant, any two rows are equal, the result is 0. So that it is not kept in the slide. That's what I am discussing now. So next, this problem, that is a gradient of f of r, which is equal to f dash of r by r. Here, this is r vector. This is scalar. It's a very beautiful problem to understand the difference between what is r scalar and what is vector r. Then we moved to directional derivative of f equal to xy plus yz plus zx in the direction of vector. Here, directional vector, we found it. One more problem, here only one function which is given. The next we concentrated a different one, directional derivative. Here two functions are there. Pi is one function, f is another function. So different problem to understand more directional derivative. So when we concentrated this directional derivative, the pi function, which is x squared yz plus 4xz square, and f x log z minus y square at this particular point, minus 1, 2, 1, completely partial differentiation, which is explained in this video lecture. Next, we concentrated unit normal vector for which this is a given function. So the normal vector, first we found what is the gradient of this particular function. To convert it into unit normal vector, we discussed that is the given vector, that is a gradient of that given vector divided by modulus of that vector. If we found it's nothing but unit normal vector. Then next we moved to the surface which is given at the 2 points. The first point 4, 1, 2. So the gradient of this function at this point, the first point we found, that is n1 vector. Same, the next point, the gradient of that particular surface of the function at this point, that is n2 vector, and we applied, this is the formula angle between two the normals, we applied it and we obtained the result. So we discussed completely in this scalar and vector point function in detail. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.